In this recording, we're going to review how to describe distributions. So when you're looking at a distribution, you can talk about its shape, which will use these words like symmetric or skewed right or skewed left. You can talk about its center, which is typically like, well, what's its mean or what's its median. We can talk about the spread of the data, which is often the standard deviation. So we've got some examples here to choose from. We've got 4 histograms and 4 descriptions. So let's just look over these possible descriptions, and then we will give you an opportunity to make some matches. How's that sound? So skewed right means the data tails off to the right. Okay. Symmetric, well, basically it looks like a mirror image of itself. It doesn't have a skewedness to one side. It looks pretty balanced. And approximately is the right adverb to put in front here. Now you notice there's 2 that are skewed right and 2 that are approximately symmetric or mound shaped. Like you can envision, you take a pail of sand and you drop it on the floor. How does it fall? It kind of falls with a big middle and it distributes evenly to both sides. So the mean for all of them is 100. So typically the balance point or the middle of the data is about 100. And the standard deviation, though, is different. So think about what that means to have a small standard deviation versus a large standard deviation. In the previous recording, we said standard deviation means a typical deviation from the mean. So if it's typically a big number, what do you think that would look like? Would it be spread out? Or would it be fairly close together? Okay. So why don't you take a moment to match up A, B, C, D if you haven't done so already. Then we'll play the recording and discuss how you did. Okay, so hopefully you took time to match those up. Well, the first one, histogram 1, is best described by a B. It's approximately symmetric. It's not perfect, but it's approximately symmetric. It has a mean of about 100. And compared to the other one that's approximately symmetric, compared to B and C, I'm not going to expect that you can determine the standard deviation just by looking at a distribution, but I'm going to expect that you can distinguish between a distribution that would have a standard deviation of 10 or one that would have a standard deviation of 40. So looking at these, a typical deviation from the mean here would be like, well, maybe around here or so. Something like that. Okay, and so that's 100, 80. So that'd be from 60 up to 140. That would be typically, most of the data's in here, whereas this one, from 90 to 110, that's 10. Okay, so most of the data's in there. That's why that makes sense. Let's look at our skewed right and skewed left. How'd you do with those? Really the only difference is the standard deviation. Which one seems to have the standard deviation of 40 versus 10? So again, the scale's different on these. Means at 100. If we got 10 in each direction, that's a typical deviation. 10 would not be typical from here. It would be like right there maybe to there, which would not be typical. But 40 would be. That's like right out here to there. Most of the data typically is between that. So the one that has the 40 is D and A. Final question for you. The next page it says, describe the distribution here in terms of shape, center, and spread. Well, we're going to talk about whether it's skewed left, skewed right, or symmetric. In fact, I'm going to give you another word. I'm going to call this a uniform distribution. Okay, so it's not skewed, but it's not really, you wouldn't say it's symmetric. It's almost like they're all the same height. Okay, so it means they're all the same, like uniforms for a job or uniforms on a team. They're all the same. What would you estimate the mean to be? And what would you estimate the standard deviation to be? Approximately. Play the recording when you're ready. Okay, so I would say the mean seems to be right around 3. And then your standard deviation, typical deviation from the mean, I would say is probably about 1, right? If you went from about 2 to 4, that would be a typical deviation. So we'll say it's about 1. Thanks for watching.